So hello everyone, welcome to the third tutorial session of the SWAYAM course Problem Solving Through Programming in C. So this course has been floated by Professor Anupam Basu from Department of CSE IIT Kharagpur, and I am Siddhant. I'm one of the three TAs who are in charge of taking this tutorial classes where we'll be discussing the week's contents very briefly and solving a few sample questions which will help you solve the assignment questions as well as in the final exam. So in this tutorial session, I'll be covering the course content for week 4, where we knew more about if-else statements and switch statement, and we just had a first look into the looping statements like for loop, while loop, and do while loop. So we'll start off by solving a few questions on if-else statement, which is kind of continued from week 3 lectures. So let us start solving this question. So the first question, let's look at the first question. So here we have a variable x with a value of 1, and then we have a nested if condition. So this is we are using a nested if, and yeah, what will be the output of this C code? You can write the answer in the chat box. Okay, so as you can see here, there are no curly braces given after x equal to 0. So there are no curly braces here. So what happens exactly? Because of the lack of curly braces, what happens? So whenever we know that if we are writing, say, some, if I is equal to j, and only then, and we are not giving any curly braces, only the next statement is executed, right? As part of the if statement, only the next statement is taken into the account. And if we want multiple statements to be executed, we have to give a curly braces, and we write all those multiple statements, and then we close with the curly braces. So this is how we usually do. But what happens here? So here, first of all, I'll just tell you the correct answer here is no output. Why? Because just look at the first if statement. So we have a if statement and we have not given any curly braces. So what is the next statement here? So the next statement is this entire if else block. So this is one compound statement. So this is considered as the next statement here. So if you have say if you want to give this multiple conditions nested if like this, so you can have this if else condition, the interior if else condition. This is treated as a single compound statement, and the first if condition, if there are curly braces, the answer will still be the same. If I give a curly braces here and here, right? So if I give curly braces here and here, the answer will still be the same, and that is exactly what happens here. The next statement that is considered after this, if x is double equal to 0, that is x logical operator equal to 0, then the next statement is this entire if else block that has been considered. And this if else block, each of the if and else statement has one statement under it. So here you can see that if the value of x is 1, and when we check with the condition that x is equal to 0, whether x is equal to 0, it's not equal to 0, right? It's false. So this entire entire compound statement that is present within this if within this if statement is not executed. So in that case, we'll have this if this entire if else block that is present within the first if statement is not executed, you'll not have any output here. Is that clear? Is there any doubts? Yes. Yeah, because the first the first of this if x is equal to 0 is evaluated, and it turns out that it's false. And once that is false, this entire if else statement which you see inside the if statement is not executed. And yeah. So anyone else has any queries? Okay. If not, then we'll move on to the next question. So let's look at the second question that I have. So we have okay, we have characters capital A and small a being compared in a if statement, and based on the comparison, we are printing out different things. So what should be the output from this code? Okay, okay, and why is that? Can you explain? Right, right. Uh, no, you said everything correct apart from the thing that option D is the answer. The answer is NPTEL here. Yes, let me tell you the answer first. So here NPTEL is the answer. Why? So here capital A and small a. Notice the peculiarity that you are seeing. You are seeing a single inverted comma here, right? Uh, with the like surrounding the capital A or small a, you have a single inverted comma. So this is the way characters are mentioned in C. So if you want to mention a character literal, so I this is a character literal, and I can mention a character literal by giving a single inverted comma on both sides of the character. That is, I'll write A and then give a single inverted comma on both sides. So now this A is actually the character A. It's not a variable or anything of that sort. It's a character literal, and every character literal, when you try to compare the character literal in a if condition, so what happens is it gets converted to its ASCII equivalent. So for every character there is a ASCII equivalent. So there is ASCII code for each character, and uh, the ASCII code for capital A, the character capital A is 65, and the ASCII code for, yes, it's 65, and for the small is 97, right? So and once it gets converted to its ASCII code and then it gets compared, you can see that the condition is reduced to is 65 less than 97. So this is true, and because it is true, the NPTEL will be printed. Is that clear? So the first thing here is that this capital A and small a are character literals because they have been enclosed in this inverted comma, single inverted comma. And the second thing to note is that when characters are compared in a if condition, they are converted to their ASCII equivalents are checked. So their ASCII equivalents for the capital A and small a are 65 and 97 respectively. Now the overall condition gets down to this, that is, if 65 is less than 97, which is true, and because it's true, you'll have the statement under the if block being executed, which is NPTEL. NPTEL is printed. So the answer here is A, option A. Yes. Return zero, yes, it's good practice to write return zero. Even if you don't write return zero, it's still the current compilers will still work fine. But you should like the good practice is to write a return zero if you are writing int main. Okay, so we will go to the next question if there are no doubts here. Um, yeah, go ahead. Yeah, you don't need any variables to write a code, right? This is still a legitimate code. This doesn't have any variables. You are just comparing some characters in a if condition and you are printing something. At no point I have used a variable in this code, right? Why do you need a variable? It's not necessary. I can write a code which will compare whether 1 is greater than 10. I can write a code, right? Instead of this, I can simply write if 1 is greater than 10, then I'll print yes, 1 is greater than 10, else I'll print no, 1 is not greater than 10. I can write a code like that, right? You don't need a variable necessarily. But yes, to have a to fulfill some purpose, to store some value at some point, you need variables. But here we are not really storing anything in any at any point, right? We are just comparing two characters and we are printing based on that. We are not storing any value anywhere. We don't need to. So we don't use variables. Yeah. Okay. And yes. Oh, okay. So this is something that I have been saying in every class. But yeah, so you go to the course page. You get a option there as problem solving session. You go there, you'll get an Excel sheet where you can get all the PPTs and the videos. Okay. Yes, please go ahead. You can also, yes, you can go ahead and ask. Actually, your voice is not clear. Can you please write it in the chat? Then I can check the chat and answer accordingly. Okay, so while Manju is asking her question, we will move on um, to the next question, which is this, where we have two integer variables a and b with values of 0 and 10. And this is actually quite similar to something that we solved in the previous tutorial session, if you remember. So just look at the question and answer what would be the output for this. Okay, some are saying true, some are saying false. Okay, so regarding the previous question, yes, okay, okay. Just a moment, let me answer Manju's question first. I'll come back to this. So, okay, so here, Manju, capital A and small a are not variables, they are characters. And to write characters in C, we can enclose them in this single inverted comma. As you can see, I have written here. We write A and then we write single inverted commas on both sides of it. That means that this is a character. It's not a variable. So, because it's not a variable, we don't really need to initialize it. It's just a character, the character A or the character small a, whatever. So these are just characters. They are not variables. So we don't need to initialize characters. They are already there. The compiler recognizes them automatically. So there is no need for initialization. Is that clear? Okay. So Okay, so here the answer, let me first tell you the answer is false. I think someone said that correctly. So here, if you remember in the previous tutorial session, we had done a very similar question, and here what we are doing is inside the if condition we are actually doing an assignment operation inside the inside the if condition. So this part is actually it's doing an assignment, and it is assigning a to 0. So the value of 0 is going to a, and also the value of 0 or the value of a is going to be the value of the entire if condition. So once the assignment operation is done, now we are basically evaluating f of a. And what is f of a? A is 0. So we are evaluating f of 0, and 0 means it's a false. So the condition itself is false. So it will go to the else part, and it will, because it will go to the else part, it will print false. So false is the answer here. Okay. If it's clear, then yes. Okay. So so here what we are doing is we are instead of writing a equal to 0, that is the comparison, that is the logical equal to operator, which would have checked if the value of a is, whether a is equal to 0 or not. So instead of writing that, what we wrote here is a equal to 0, single equal to, that means it's an assignment operation. So this is a logical equals operator, equals to, and this is the assignment operator. So there is this difference between these two. So because we are doing an assignment operation and not a comparison operation, that is the logical operation, so what will happen here is first this assignment operation will take place. A will have the value 0, and then the if condition will evaluate the value, will evaluate whatever value is contained in A. That is, after this assignment operation, the if condition will check if of A. Now if of A is 0, so if of 0, and 0, if we are writing the condition as 0, that means it is false. Any non-zero, if you had written any non-zero thing, then it would have been true. So in that case, you would have got true as the print. But here we are writing if of a equal to 0, where a is having the value of 0, like a gets the value of 0 because of this assignment operation, and you write if of a, that means the if of a operation is taking place next, that is the condition checking, and a is 0. So technically you are checking if of 0, that means it's false. 0, that's the condition, that is the conditional value, that is false. And because it is false, it goes to the else statement. The else statement is executed, like the else block is executed, and you have false as the output. Clear? You can also, yeah, okay. All right, so the next, yes, yes, we have. Because if after this assignment operation, the if is basically checking this if of a. If you write if you write if of 0 as your conditional statement, then this will be false, like the the conditional value of this statement is false, and in that case this condition will not be executed, the else part will be executed. This will be executed because whenever we write if else statement, what happens if this condition, if the condition written in the if statement is true, then the if part is executed. If the condition written in the if statement is false, then the else part is executed. So what is happening here when you are writing if of a, right? like if of a equal to 0, but forget about the assignment operation. The assignment operation has happened and a has the value of 0. Now technically this reduces into if of a, and if of a means you're saying that if of 0, and if of 0 means the conditional value is 0. If the conditional value is 0, that means it's false. And if it's false, if the conditional value is false, whatever condition I've written in the if statement is false, then it goes to the else part, and the else part here has printf false. Okay. Yes, sir. Yes. If you had, okay, okay, if you had written a equal to 1, then you would have got the answer as true, because you are assigning a to 1 and then you are checking if of a, that is if of 1, that means the conditional value is 1, which is true, and you would have got the output. The if part would have been executed, like the if block, so you would have got true as the output. Float value is, yes, float value is possible. You can write 1.1, which is also true. So any non-zero condition, any in the conditional statement, if you write any non-zero value, it is considered as true. So if I write if a is equal to, say if a equal to, and if float of a, like a was a floating point, and I would have written if a equal to minus 2.2, still true, because it would check the value of, it would do the assignment operation, then it checks the value of, like a is a conditional statement, and a is something that is not 0, and if it's not 0, it's true. So you would have got here the output being printed as true. Okay. All right. So I think some of you have already answered the next question. So I'll just okay. Yeah. All right. So I'll yeah. Let us see what the answer will be. Hmm. Yeah. Right. It will be option B. Okay. So you have X, Y, and Z, three different uh, three different variables, and y and z are allotted the value of 5 each, and we are writing the statement which is x equal to y double equals z. This is the logical equals to operator. So here the operation is basically this. So what is this operation? We are comparing a value of 5 with a value of 5, so it is true. Now if it is true and you are trying to save that in an integer variable, so you are trying to do this, right? But this is an integer, so this has to be converted into an integer. So when this is converted to an integer, you get a value of 1. So true, when you convert from boolean, which is true or false, to integer, true value will be converted to 1, false value will be converted to 0. Okay. So here x will have the value of 1, and when you print it, you will get the output as 1. Okay. So is this clear? Okay. Boolean is basically, so Boolean data type is basically having two values, true and false. Okay. So when we convert from Boolean to int, you will have the true value will be converted to 1, false value will be converted to 0. And if you convert to from int to Boolean, like we did in the previous question, so 0 will be false and anything else will be true. Yeah. Uh, yes, Yashwant, do you have a question? No? Anyone else? Yes, yes, please go ahead. Mm-hmm. Mm-hmm. Yeah, yeah. No, no, there is no chance that x equal to 5 because the operation y, whether checking whether y is equal to z will occur first, and once that occurs, you will have a boolean value which is true or false. Here it is true, and when you convert a boolean to int, like I wrote down here, if you try to convert it boolean to int, then true will always give you a value of 1. It will never give you a value other than 1, even if that is also true. Okay. No, still not. Still no. So, uh, okay, you need to understand that the operation, this y double equal to z, this operation occurs first, and once that operation occurs, only then you have the assignment operation happening, which is x equal to whatever you get from this section, right? So even if you write int again here, then first of all it will give you a compilation error because you are defining x twice. Like you initialize you declared x in the first statement as int x, and again if you write int x equal to so and so, it will give you a compilation error. But even if you remove from the first line and you write and you define x in the second line for itself, still you will get the value of 1. You will not get any other value. Okay. So you want to have a floating point x. Okay, yeah, that's fine. Still you will get 1.0, like 1.6 zeros, like followed by 6 zeros. That will be your output if you print percentage %f only, then yeah. No, I'm just saying that if x was a floating point variable and you tried to print percentage using percentage %f, not d, then you would have got 1.000000, something like that. Okay. Okay. Yeah. Yes. In that case, you have to initialize as float. But otherwise, uh, yeah, it's fine. Like the way it is, the answer will still be the same. It will still be 1. Okay. Yes. 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 That's correct. Okay. So we'll move on to the next question. So, okay. So this question implements the postfix operators, which is a minus minus, and the prefix operation, which is plus plus a. So you keeping that in. Okay, okay. No, what will be the answer here? Only true will be printed, only false will be printed, both will be printed. Okay. Okay, ternary operators with multiple operation. Yes, ternary operators with multiple operations. First of all, I wouldn't recommend you to write ternary operators with multiple, like combined ternary, multiple ternary operators, because it's not very good practice to do that. It makes things unnecessarily complicated. But yes, probably we can discuss a question. Um, but I think in most of the cases, it will be the evaluation will be the outer operator followed by the inner operator. I think I discussed a question in the previous class, right? If not, anyway, we can discuss it again here at the end of the class. Please remind me at the end of the class to discuss that. And okay, so if what if x equal to y equal to z, I think that would give us a invalid statement, like a compilation error, if we write it in the form that x equal to y equal to z. But yeah, I have to check this out. But I think in as far as I know, it should be a compilation error. All right. So here, y- yes. So if you write x equal to y equal to z, in this case it will be a compilation error. That's what I'm saying. But yeah, I have to check that. Okay, is equal to 5. What? You're getting an answer equal to 5? Is that what you're saying? No, it's not a condition anymore. It's an assignment. So this is one assignment and this is another assignment. So you are basically writing two assignments. It's not a condition anymore. It's not a conditional operation anymore. That's why I'm saying it might give you error, but yeah, it might not as well. In case it does not give an error, you could think of in this sense, what kind of associativity does the assignment operation have? So you have to check the associativity of the assignment operator. Okay, so if it has a left to right associativity, sorry, right to left associativity, then you would have z equal to y, like y is equal to z, sorry. You would have y equal to z and then x equal to y, something of that sort. Okay, so in that case you would have probably a value of 5 being printed, but you have to check that out. I'm not sure about the associativity. I don't remember what the associativity of the assignment operation is. Uh, yeah, yes, okay, yes, okay. So all values became 8. Yeah, that makes sense, right? So yeah, that's basically what I was saying. Someone said that associativity is right to left. I think that is correct. So first, the first operation here will be y equal to z, and in your case, z is having the value of 8. So you have y is equal to z. Okay, this is the first operation. Then you have the operation x equal to y. Now, after y is equal to z, y also had the value of 8, and you're doing x equal to y. So x also has the value of 8. So everything came out to be 8. Is that? Oh, okay. Uh, Sorry, that that requires actually a lot of time. So I would ask you to go back to, I think, the second tutorial class, and you can look at precedence and associativity. I think I have discussed it in quite some detail. Like I think around half an hour we discussed only regarding this. So you can probably go back and visit that video. Okay. Okay. So here, first of all, let me say the answer is option C. Okay. Why? Let us check that. So the first we can see that if a minus minus, that's the first statement that we are writing. So what is a minus minus? It is a postfix operation, postfix decrement operation on the operand a. All right. So what happens then? So postfix basically means that it will evaluate, or the evaluation, the return value of a postfix operation. So let me just write that down. So postfix operation, when you do it, the return value is return value is the original value, right? And when you do a prefix operation, then the return value is the modified value. Okay. So in a postfix operation, the return value is the original value, that is whatever operand you are, whatever value you are giving to it, that itself will come back to you. So here, if a minus minus, so what happens here is if of 1, because a minus minus, the postfix thing will occur later. Like you can think of it in this manner that the post increment that should happen, it will occur after. Um, okay, all right. For making you understand better, I'll just say that the postfix operation will occur after the evaluation of the if statement. Okay, but later on we'll discuss a question where I'll tell you actually what happens in a postfix and prefix operation. Okay, so for now, let us just understand that whenever we encounter a postfix operation, that means that first the evaluation will take place and then the increment will take place. For now, let's just have that understanding. So what happens here is if a minus minus, that means if 1 will be evaluated. So basically, we are evaluating if of 1, and then the increment is happening and a's value will sorry, decrement is happening, and then a value will become 0 after the after if of 1 is already evaluated. So if of 1 true is printed, right? You get true already printed. Now what happens is a separate if condition now. So after this, while this if condition is evaluated, the a value has already become 0. Okay, the a value has already become 0. Now, in the next if statement, we are doing a prefix increment operation. So a value will become, so in a prefix operation, the modified value is returned. So the increment operation here, it occurs. So a is equal to a plus 1. That means a will become 1, and that 1 will be returned back here. So we are evaluating again if of 1. All right. So false will be printed. Okay, is that clear? Why true and false both were printed? Okay, all right. So uh, let that, if that is clear, we will go on to the next part, which is two questions on the printf statement or the printf function. So as you know, printf is a predefined function which is in the stdio .h. Okay, okay. And can you explain why? Okay, and mhm. Yes, right. So the return value of printf is the number of characters being printed. Okay, so here the number of characters in being printed is 1, so 3, that is the only thing getting printed here, so that is a return value of 1. Usually you don't really need any we don't really use the return value from a print statement, but here we are assigning it to a variable x, and hence that will have a value of 1, and you'll have 31 as the answer, because in the first statement you printed out, so printing will still occur. You're writing printf 3 means printf in double inverted comma 3, that means 3 will be printed for sure, but the return from printf will be the number of characters that the printf statement has printed, that is 1, and that is being stored in the variable x, and when you print x you will get 1 as the output. So 3 and 1 is that. Okay, I can repeat this. So when we print out, so the first thing that you need to know is what kind of statement is a printf statement. So the printf statement prints whatever string you give to it. So this is a string which is containing only one character. So let me write this down. So this is a string containing one character. Okay, there is a single character, and that character is 3. Okay, so the printf statement prints this. So what it does is it prints it to the screen. Prints it to the screen. So what the printf statement does is it prints whatever string we give to it to the screen, but the return value of the printf function. So like we are talking about why we need to do a return 0. So there is a return value from every function. Yes, so the return value of the printf statement is the number of characters it has printed. So the number of characters it has printed here is only one, because it has printed only a single character, and that return that return value that we are getting from the printf statement, I am saving it to a integer variable which is x, and so x will have a value of 1, x equal to 1 in that case, because we are printing only a single character. So printf will have a return value of 1, and that is being stored in the variable x, and when we are printing x, you will have 1 being printed. So here when we evaluate the second line, you will get an output of 3, because 3 is printed, and the return value of the printf statement is 1, because only a single character is printed. Then you print x, which has 1 stored in it, so you will have 3 and 1 being printed. So now someone asked, what if we print 33? Okay, yeah, what if we print 33? So if we write printf 33, so x equal to printf 33, and then printf, yes, exactly, so the answer will be 332. So you will have 33 printed, x will be 2, and you will print 2. Okay, then returns 2, yes. Okay, so mhm. No, it goes to the printf percentage d. The printf, the return, I'm not talking about the return from the main function, I'm talking about the return from the printf function. So printf is a already predefined function in the library. So the printf, when the return value from the printf function is, in this case it is 1. If you write 33, if you printf 33, the return value is 2. Okay, uh, is that clear? So, so it will go on evaluating the statement. So x equal to printf of 3 in the string 3. That basically is a single statement. After which it will evaluate that x value has become 1, and then it will go to the next statement. It's not going to the return statement directly. I'm talking about the return from the printf statement. When someone wrote down the printf statement, the developer, the printf statement was also has a return value, right? So I'm talking about that return value, not the int main return value. Okay. Uh-huh. Then that would have okay. So then you would have ABCD 4 being printed because there are four characters. ABCD 4 characters. Then printf, the return from printf would be 4, and x would become 4. So you will have ABCD, which is already printed, and then 4 being printed. Okay. All right. If we write x equal to printf of a, the answer will be a1. As you can, someone has already answered correctly. What if we keep /n after 3, like printf 3/n? Okay, that's a very good question. It's a very good question. So, so what if, okay, so what if we write printf 3/n? What will happen in this case? So I'm writing x equal to this, and then I'm trying to print %d x. What will happen? So you'll have 3 and 1. Yes. Does anyone have any doubts regarding this? Why 3 and 1 would be printed? So it's okay. Okay. So this is the escape sequence. It is not really considered by the print statement because it's a escape sequence. It's just plainly ignored by the print statement. So you still have one character. Okay, for the next question. Okay. Yes, this is an interesting question. Yeah, just go ahead with the doubt. Mm-hmm. Choose two. Okay. 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 Ideally, it should not. Let me think about it. It's a escape sequence. It's usually not considered within the string. Okay. I'll check that out and get back to you. Okay. So you're saying it should be 3 2, not this, but this. Uh-huh. Uh-huh. 3, 4, then 3. Okay. Okay. Yeah, then it considers the escape sequences. Okay, fine. So although it does not really print anything as such, but it still considers the escape sequence as a character. That makes sense. Okay. Okay. No, I haven't. I haven't ever tried this, but yes. So there is a correction here. I'd like to correct myself. So escape sequences are actually considered as characters, considered and counted as characters. Let me write that. Yes. So what if I write x equal to printf inside the printf I write 3/n, and then I print the value of x. What will happen? So here x is int. I don't need to really mention that, but yes, okay. So what happens in this case? You have 3 being printed, and /n is another character, which makes it go to the next line. And when we try to print x, so what will be the return value from uh, this printf 3 slash n? So the printf value will be 2. Like the return value will be 2 because there are two characters, 3 and the escape sequence, which is slash n. Yeah, thanks for asking that question. This is very important. I learned something new as well. Okay, so you have 3 being printed, and then you have uh, in the next line, because it goes to the next line, because there is slash n that you have written. 2 is printed when the x value is being printed. It's 2, so 3 and 2 are being printed. Is that clear now? Okay. All right. Okay. So can someone answer the other question that is there? Okay. Okay. Why do you think so? So what if I tell you the answer is D? What if I tell you the answer is D? So like in a yes, yes, yeah, mm-hmm, yes, yes, mm-hmm, mm-hmm, yeah. No, but I'm telling you the answer is option D. I'm telling that the answer is 0 and 1 1, not 0 and 1 2. Yes. Yes, exactly. That's what I'm asking. You can try it out with your compiler. No need to believe me, but you can try it out on an online compiler, or if you have one on your computer, you can try it out. You will get 0 and 1 1. So this brings me to this point where I'm questioning what is this? Like, what is a logical AND operation? Like, what happens when you do a logical? Okay. Mm-hmm. You understood? Okay, okay. Can you explain? Exactly. Yes. So what happens here is we are this. What happens is the nature of logical AND. So let me write the truth table for logical AND operation. So we have say A, B, and I'm doing A and B. Okay. So this is 0, this is 0, this is 0, this is 0, this is 1, this is 0, this is 1, this is 0, this is 0. This is 1, this is 1, this is 1. This is what two of you already said. So what happens? So here, this I plus plus is my A. So here, let me write this. I plus plus is A, and plus plus J is B, and I'm doing a AND operation with those two. Okay, so here A, as one of you correctly, I think multiple of you already explained. So I plus plus is basically the return value from that is 0. I is 0. The return value is, from that is 0. So what happens after that? So that means I'm taking the condition where it is 0. One of the condition is already false. I reached AND, but I know that one of the conditions is already false. Do I really need to check the second condition? That is the thing. Why do I need to check the second condition? I don't. So I just move out of the entire thing. I know that it's false. The compiler knows that it's false. It does not need to check the second condition. So the second condition is straight away ignored if the first condition is false. And that is what leads to this value to, okay, so you know that the AND is false. Okay, so 0, you understood why this 0 came out as a print. Then you know that after, due to the post increment operation, after the after the AND operation, what happened after the AND means, after knowing that the entire value is false, you know that the I value got incremented by 1, so it became I equal to 1 in this statement, right? You know that as well. And then you print I and j. So I and j are 1 and 1, because this part did not get evaluated at all, because the first condition itself is false. So you don't need to evaluate the second condition, and that is how logical AND works. So this is pretty, yes, this is pretty, yeah, exactly. Now this brings us to a very say a very important juncture. I would like to know if you want to know something more advanced than this, like how exactly this works. But anyway, we will figure that out in. Okay, okay, I can explain it again. So okay, we have the first condition, that is I plus plus, right? So mhm, I plus plus is the condition. So in that case, I plus plus means its return value of 0. That operator gives a return value of 0. So I know that my first condition is false because it's 0. That means it's false. And because I know that my first condition is false, I will not really check the second condition with a, if there is a logical AND or logical OR operator. In such cases, okay, then let me not talk about logical OR. If there is a logical AND operator and the first condition is false, I'll not even check the second condition. I'll straight away say that the evaluation, the answer is 0 or false, and false means 0 will be printed. And then the increment has, however, occurred after the return. The increment has occurred, so I has become 1 already. Although we evaluated it with 0, the I value has become 1 already, and the j value has not been changed because we did not evaluate the second expression. Now I and j are both 1. In that case, you got 0 and 1 1 being printed. Now what are the other questions? If I replace, yes, yes, if we evaluate it, it will be 2, yes, but we don't evaluate it here. If I is equal to 1 here, for example, someone has asked, what if we take I as 1 and j as 1 in the initialization step? In that case, the first would be 1, I would be 1, the return value from I plus plus would be 1. The return value from and because this is true, the first expression is true, it will go and evaluate the second expression, which will be plus plus j, and j value will be incremented by 1 first and then evaluated and then compared. So j will become 2. So we are comparing basically 1 logical and 2, which is true. Your answer will be 1, and then it will be 2 2, because you're saying I is 1 in the beginning, So I had been has been incremented to 2. So the answer will be 1 and then 2 2. Okay. Uh, yeah, these are the practice questions for the assignment, not the assignment questions. Okay. So just I'll give, yes. If we give just okay, bitwise and does not work in this way. I cannot for sure say that it will be always true or false, because bitwise and it compares every bit. Like you have, say, I write 1 byte, say I write something which contains only 1 byte of information. So I write all the 8 bits of data, and I write all the 8 bits of the other the second expression or second data. So I bitwise and j, if I write that. Okay, so I write bitwise the binary equivalent of I, the binary equivalent of j, and I do that AND operation with every corresponding binary value. Like if it's 100 100 something, and the binary equivalent of j is similarly 10 10 10 something. So the last binary digit of both I and j, I will do a AND operation across that. Then the second last binary digit of I and j, I'll do a AND operation across that. And similarly, I'll do a AND operation with each of this binary uh, binary set of digits, corresponding binary digits. And after that, whatever I get as my final answer from all this binary bitwise binary operations, that will be that I'll uh, convert back to a what do you say, I'll convert it back to our decimal to check whether it's actually 0. If everything is 0, only then it will be 0, right? So it needs to have everything as 0, only then. uh, so you understood what the difference is in between the bitwise AND operation and the. Yes, they are completely different, right? Yes. Can you come again? I couldn't hear the second part. Mm-hmm. Yes. Yes, it doesn't check the second part. Yes. Mm-hmm. Yes, it checks the second part, because bitwise and does not is. So this is there's a big difference between logical and bitwise and. So bitwise and is only for bitwise operation. It does on the binary scale. It will not compare expressions. So this happens only when you're comparing expressions on this scale. Bitwise AND is usually used with any kind of integer operators and so on. Like two numbers you can do bitwise AND operation with that. But this can be used for relations as well. So there is a difference. And yeah, you said that as well, that there is a difference between logical and bitwise AND. Yes. It will evaluate both. So both operands are required for a bitwise, and both expressions are absolutely required. You understand, right? Uh-huh. Yes. Mm-hmm. Yeah. Okay. So there was one other question. What if I is equal to 3 and j is equal to 4? So in that case, you will have 1, and then it will be 4 and 5. Yes, I think Manju is correct here. So in binary addition, 1 and 1 will give you 1, and 1 and 0 will give you 0. So the concept of AND remains the same, just that it will be on a bitwise level if you are using a bitwise AND. That is the thing. Uh, okay. 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 I'll do a very small example. So let me say I'm writing A and B. Although this is not really relevant for you guys for this course, but yeah, I'll just explain in very short. So let's say the binary equivalent. I'm writing A and B here, as you can see, and the binary equivalent of this is 10110100 something. I need 8 digits. Okay, yeah, 8. And then this is some 10110100, let's say. So I do bitwise operation across every 2 digits. So 0 and 1 bitwise AND will give you 0. This is 0, this is 0, this is 0, this is 0, this is 1, this is 0, and this is 0. So basically your answer is this. So C, when you do A and B, that is A bitwise and B, your answer is this. You can convert it to decimal and check what is the value of this. So there's 2 to the power 0, 2 to the power 1, 2, 3, 4, 5, 2 to the power 5. Is this 120? Is it? No, no, not 120. What is 2 to the power 5 is? 4, 8, 16, 64, I think. Yeah. So that is, this binary expression is the value of A and B. So that is how bitwise AND works. Okay. So I'll, yes, what? I couldn't get you. Yes, yes, but the concept, the truth table remains the same. So this is the truth table of and it remains the same for both the operations. Just the thing is, the logical AND compares with two different. The logical AND compares the two different relations, and the bitwise AND compares does a bitwise comparison of the binary digits. So it's about what are the operands, how it works. The concept of and concept of OR remains the same for both. Okay. Okay. So before we go to the next part, I would like to just point out, or rather give you a clue for later, that this, when we say it's a logical AND, that is something which is called a sequence point. It generates a sequence point in the code, as is a semicolon. Semicolon is also a sequence point. Okay, just to know. I'll cover this later. I'll come back to this. I have a very interesting question for you towards the end. Um, we'll discuss sequence points there very briefly, but I'll like, sequence points is probably something that, this is a basic course of C. I don't think you need it, but yeah, that is why I will go. I'll explain it at the end so that only those who are interested in knowing a little bit advanced stuff, you can understand that. Yes, yeah, go ahead. Yes. Uh-huh. Yes. So 1 and 4, 5 are correct answers. Like, I think someone answered that, right? 1 and 4, 5. Yes. Yeah, because you see, when I is equal to 3 and j is equal to 4, that was what is being asked, right? So I plus plus meaning 3, I plus plus meaning 3, uh, 3 means true. Now, logical and, so I value increased to 4. We are going for the second expression. Plus plus j, 4 to 5. So expression is 5. So we are comparing 3 and 5. 3 and 5, true and true, true, 1, true. The entire expression is true. So 1 will be printed, right? And then I and j. What are I and j? 4 and 5 respectively. Yes, 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 right. Okay, all right. So we'll go to the theory. I guess the next part is just theory. Yes, it's theory. So we have, okay, yeah, no, we have a question as well. All right, so let's look at switch statements. Switch statements was something that was covered in this week four's lectures. So this is how there is a syntax for a switch statement. You have an expression in a. Can you just mute? I think the voice is echoing because of that. Yeah. So in a switch, you write an expression inside a switch statement, and based on the evaluation of the expression is evaluated. Whatever value you get from that, whether that value is matching with x or with y, or it is not matching with either of them. So depending on that, this code blocks will be executed. So say you evaluated this first expression, which is written in braces after switch, and you got a value which is equal to x. So you, the first case is x, that means it is compared with the value of x, and it's true, so it's executed. And then you use something called a break statement, which is a flow control statement. So what the break statement does is it just breaks you out of this switch case block. So it goes to after the switch case block. Sorry, it goes to after the switch case block. That's what it does. Now, if your y case y is executed, it's if it is equal to case y, then what happens? Then you have the code block inside case y is executed, and then it breaks. If it is, say, the value is something else, it is not equal to either x or y, then the default part will be executed. So that is a different way of writing the if else statement. Okay, so let us look at this question, and I think some of you have already answered this correctly. The answer will be C, yes, because there is no break after this 2. So when this x, switch of x is the expression, and x has a value of 1. So you go and see this case and case 1. So case 1, yes, you print, you have to execute the code block inside case 1. So execute that, choice is 1, printed, but there is no break statement. So it automatically goes and goes to the next case. Here the next case is the default case. So it goes to the default case, prints the default case. All right. So yeah, it prints the default case, and you have choice other than 1 also printed. Yes. Uh-huh. Yeah, if you write break here, then only choice is 1 is printed. Nothing else will be printed. Syntax of nested switch statement. Okay. No. I understood that. But why do you need to write a nested if statement, a nested switch statement? It doesn't make any sense, right? Can you just write it? Can you write it in the chat? Actually, there is a lot of background noise coming. I cannot hear. Can you please write it in the chat? Yeah. Okay. Yeah. Please write it in the chat. I'll answer whatever question you have. Please write it in the chat. Okay. So yeah, Balram Singh, I'll come back to this ternary if ternary statement, nested ternary at the end of the class. Uh, Victory. What if case 2 is also included without break? Then case 2 will also be printed. if there are no breaks, it will just keep on printing until the break is encountered, or keep on executing until a break is encountered. B, then B plus A, okay, else B minus C, yes, right, Harshit, this is correct. So this is basically how this ternary statement would be written. Very good. So I think someone else also asked regarding nested ternary statements. You can also have a look at the question that Balram has asked and Harshit has answered. Yeah, this is a good example. So the inner statement is evaluated like, yeah, this is the if else equivalent of the nested ternary statement in this case. Yeah, correct. So if there is still doubt, then you can ask me at the end of the class and I'll explain that. Okay, I'll go to a new page. Should I? Alright, let's have kind of a new page here. Okay, so which one did you not understand? The switch statement or this ternary operation statement? Okay, okay. Yeah, I'll quickly answer this. So maybe you guys can have a look. So B less than A, then A less than C, A minus B, B plus A, B minus C. So this is say the value of some Y I'm saving. So this is basically equal to writing like this. If, sorry, B greater than A, then I check if A greater than C. I say Y is equal to A minus B, right? And else Y is equal to B plus A. This is over. Else Y is equal to B minus C. So this is how I would write it. So these two statements are equivalent. The if nested if and this nested ternary. Yes, Narayana, sorry. Can you raise your hand? Yeah. Hello. Yeah. Can you? Yes. If you have any doubts, you can ask me. Yeah. Sorry. This is B less than A. Oh my God, I wrote it wrong. Yeah. Please go ahead. Yes. Oh. Okay. Sorry about that again. Yeah. Yeah. You understood, right? Mm-hmm. Hmm. Yes. So uh, this part, this is a ternary if-else statement. So if A is less than C is true, then A minus B will be returned from this. And if A less than C is false, then B plus A will be returned from this. And this part is the truth part of B less than A, and B minus C is the false part of B less than A. So yeah, like I don't know how else to explain. This is the simplest way I've written it down as a nested if else statement. Like it should be so. This is the first condition, which is B less than A. Yeah, okay. Uh, all right. Yes, if you have any question, you can ask. Okay. Veturi, right. So if break is not included, when whichever cases are present are printed without any relevance to X. Okay. Not really. It's only if there is a at some point you have case X which is equal to whatever switch expression you have. From there onwards, everything will be printed in absence of a break statement. Because if it is false, then it will not go into that block at all until once it turns out to be true, and then it starts executing, and until it encounters a break, it won't stop. Yeah, but let me check this out. I like these questions. Yeah. Yes, break can be used in a while loop. It is mostly used in looping statements, yes, but it also has to be used in a switch case statement. Okay. All right. So I'll just quickly move to more questions on switch statement. Yeah, we are a bit late. Okay, so switch some temperature in Celsius. So this is just part of a code. So don't think that temperature in Celsius is not defined, so it will give an error. No, it will not. I'm just writing just a part of the code. So if you evaluate this part manually, then what happens? Jump. Yeah, why would you use jump statements in the first place? Yes, like if you're talking about break and continue. The jump statements, flow control, we call them flow control statements, but yes, okay, yeah, we use them inside switch case or inside the inside the loops. Yes, you don't need to use them inside a if. That is by itself, like, you don't use them because you don't need to. The Yes. Yes, exactly. Or you can use it in inside a switch. In switch, it is required to use it. Otherwise, you saw what happened. So that those kind of cases where in the absence of break, it keeps on executing and doing whatever it wants. It's called a fall through. So that is what happened in the previous question. Yeah. No, you cannot. No, you cannot because continue has a different purpose. It goes to the next iteration of the loop, and here there is no iteration as such of the loop, so you cannot use continue inside a switch statement. But yeah, I think most of them don't know continue statement because it's not covered in this week's lecture. I think it's week 5, and it's covered in week 5. So yeah, we'll see a few questions in the next tutorial session regarding the break and continue statement. Okay. Okay. So can you answer this question? Yeah, I think yeah. Good, good, good. So this will give you a compilation error. So answer will be C here. And what about this one? This will be a compilation error again. So great. And why will both of this be compilation errors? Uh, why? Okay. So first of all, this is invalid. This is the point where it, like, you can write case 35. That means it will check the temperature in Celsius with 35, but you cannot write case less than 35. If you want to write this, if you want to mean this, that anything that is less than 35 is you want to print hot day. So you write like this: case 1, case 2, case 3, case 4, all the way till case 35. And then you write printf, whatever, hot day. Alright. So if you want this to be printed for all values within 1 and 35 integer values, You will have to write it in this manner, not less than invalid in this case. Okay, uh, so it will give you a compilation error. What about the second question? You have, so this will be the problem. This is a floating point value, and switch can use only integers. Switch expression can have only integers. Can have also characters. Characters can be there. Characters are basically, they have their ASCII equivalents, integer ASCII equivalent. So yes, characters as well can have integers or characters. Okay, so that is why you will get compilation error. Yes, Satya, can you, Satyan? Yeah, do you have any question? Yeah, you can stop raising your hand, I guess. Okay. Yes. I couldn't get your question. Can you come again? So the second question has this issue that switch expressions can be only integers or characters. So the num value here is 5.6, which is a floating point value. So because it's a floating point value, switch statement cannot evaluate it. Like the expression itself is invalid. Only integers. You can write only integers. So you can write only int num 5, int num 6 in this case. Okay. Yes. Yes. Okay. So yeah. So we have the loop statements that are, you'll be using them very frequently. It's very heavily used in C. And there are three kinds of looping statements: for loop, while loop, do while loop. And I'm sure you have already gone through all this stuff. So for loop takes maximum of three arguments. First is and this I here is called a iterator, and it iterates from 0 up till the value of 10, and with increments in 2. So you can see here the increment occurs at the very end while the condition checking occurs first. Okay, so I starts from 0, the condition checking occurs here in the beginning. If the condition is true, the interior block is executed, and then the increment happens and I becomes 2, and then again it goes and checks the condition. If I is less than equal to 10, yes, it still is, then again this code block is executed, then again increment, and so on till it goes outside this condition. That is this till the I value becomes greater than 10, it keeps looping. Why it's called a looping statement? Because it loops again and again over the same block of statements. So this is the code block that it loops again and again over. Okay, so that is the for loop. Then you have the while loop, which is completely similar, apart from the thing that you have to do the increment by yourself in this. There is no inbuilt increment counter for this, so you can use it for sentinel controlled it's a sentinel controlled statement. The earlier one was a counter controlled statement. I think this is the syntax, or this is the terminology that has been used by the professor in the classes. So sentinel controlled means you can give some other expression here inside the if block in order to check. Say I want to check if n percentage I is 0 or not. While n percentage I is non-zero, I keep on doing whatever I want. Once it hits 0, I don't want, I want the loop to finish up then. So those kind of things is also possible, where it's more like sentinel controlled, and here it is in the for loop it was more counter controlled. You can do both with either, but usually the while loop is used more towards sentinel controlled approach, and the for loop is used more for the counter controlled approach. Okay, now the do while loop has this specific thing where the iteration happens at least once. No matter what the case, your iteration will happen once. Because why? Because the condition checking occurs at the end of the statement. So first the code block is executed, and only then the condition starts checking. So even if the condition was false to begin with, you will still have the code run once before the condition is checked. So once the condition is checked, it found it is false, so it will exit. But that first condition check will happen after the entire code is, like, the block of code inside the do while loop has been executed at least once. So that is the specific thing about this do while loop, that the code execution, the block of code inside the do while loop executes minimum of one time. Okay, all right. So now we have two more questions, and yeah, you can try to answer both of them. This will be our crowning glory question. So I'll spend some, yeah, maybe you should come to that. Okay, yeah. This I'll discuss in much detail, but I think you should be able to answer this question as well, which is uh, the trick to the first question, I would say, is just take any integer and do the operations on them and answer the question. That is the simplest way to answer this kind of question. So which asks you that what does this program do exactly. So you just take an example, try to that, but don't take any example like I'll take 0. So nothing will happen. It's a trivial solution. So you just take any random variable, random value like 1 2 3 4 or whatever, and calculate what happens on that. Okay, and the second one we will discuss. That's the interesting one. And yeah, so okay, let's see if you have any answers for me. Okay, okay. Oh, good. So a lot of you have answered correctly. Okay, so let's see. The first question, the question on the left side. So you have, I'll just take an integer, say 1 2 3 or something. N is equal to 1 to 3. And I'll start computation with this in the first iteration. So what happens when we iterate the first time? So when I said sentinel control, this is what I meant, n not equal to 0. So this is something that we are not specifying. We don't know how many times it will run, but yeah, we specified a condition for it to exit. So yeah, let it run for whatever iterations it does. So in the first iteration, we do y is equal to n percentage 10. So 123 percentage 10, and what would that be? That would be 12. X equal to x minus y. So x is 0 initially, x minus y, which is minus 12. Oh, what am I writing? It's 3. So it's minus 3. This is 3. So this is minus 3. 0 minus 3 is, yeah. So remainder operation. 123 percentage 10 is 3, and x is x minus y, which is 0 minus 3, which is minus 3. Now n is n by 10, so n was 123 divided by 10, but it's an integer, so only 12 is retained. So this is the first iteration. So before the next iteration, it checks n is not equal to 0. Yes, it's not equal to 0. So there will be a second iteration here. So in the second iteration, what happens? Y n percentage 10, so 12 percentage 10, that is 2. Then x is x minus y, so x is minus 3, and minus y, minus y, it's minus 2, so it's minus 5. And n is n by 10, so 12 by 10, you get 1 because it's an integer. Then you have the third iteration. Third iteration, y, because n is still not equal to 0, so it keeps continuing. So y is 1 percentage 10, which is 1. X is minus 5 minus 1, you get minus 6. So and n is 1 by 10, which is now 0. It's 0.1, so only the integer part is retained, so n is 0. Now n became 0, so next time the condition is checked, it's false, so the while loop stops executing. It goes to the next one, and x is printed, which is what? Minus 6, right? So minus 6 is what? The negative of the sum of the numbers, so sum of the digits. So it's B, option B. This is the answer. Okay, so I see that there are a few. Okay, cool. All right, so for the second question, the answer will be 2. Which one? The first question? Okay. So I have taken just any random integer, which is 123, and for the first case, when we check the condition, n is not equal to 0, so 123 is not equal to 0, which is true. So this entire while block will execute. So the first iteration, this is the first time we are iterating inside the while loop. So y is equal to 123 percentage 10. That is what we are doing, and that is 3. The remainder operation, that will give you 3. Then x equal to x minus y, so x is 0 initially, and so 0 minus 3 is minus 3, and then we do n is equal to n by 10, so 123 divided by 10, which is 12. Actually it's 12.3, but you see n is an integer, so only the integer part will be retained. The part after the decimal will be just ignored, so it will be 12. Then we go and check, is 12 not equal to 0? True. So we go on to the second iteration. So we do y equal to n percentage 10. N is now 12 from the previous iteration. So 12 percentage 10 is 2. And then x equal to minus 3 from before. So minus 3 minus y, which is 2. So minus 5. X becomes minus 5. Now n is equal to 12 by 10, which is 1, because n is an integer, and we go and check if 1 is not equal to 0. Yes, that is true. 1 is not equal to 0. So you go on and do the third iteration. In the third iteration, y is equal to 1 percentage 10, which is 1, and x is minus 5 minus y, which is 1, so it becomes minus 6, and n becomes 1 by 10, 1 by n by 10, which is 1 by 10, and becomes 0.1. That means it's 0 because n is an integer. Now if we go and check, is 0 not equal to 0? This is false because 0 is equal to 0, so it's false. So the while loop stops. It stops executing, and you get the printf statement, which is output is minus 6. And what is minus 6? We took a number 123 and we got an answer of minus 6. So it's basically the sum of the numbers negative of that. So that is exactly what we are doing as well. We're just adding up, we are just subtracting the sum of numbers, right? I hope that is clear. Yeah, because x is being printed, right? So that is the output, isn't it? Yes, x value is minus 6. I showed you the 3 iterations and how the x value came to be minus 6, right? Like initially it was 0, it became minus 3 in the first iteration. Then in the second iteration, it became from minus 3 to minus 5. And then in the third iteration, it became from minus 5 to minus 6. And finally, after the third iteration, the while loop exits. And when the while loop exits, the x value is minus 6. So that is what is printed. So like the output is, this will be printed. Output is equal to minus 6. And what is that? That is actually, you added up the numbers, you subtracted the numbers from 0. So basically, it was kind of the negative of the sum of the numbers. Okay. Now can someone explain to me why the value for the second question is 2? Yes. No, what did you say at the end? I didn't get it. The value incremented to 3, but it gave a. Okay. Sorry, I didn't understand any of that. But okay. Yeah, but why is the post increment not happening? Can you justify it? Yes, yes. Just a moment. Uh, okay. Yeah, yeah. Okay. Mm-hmm. Mm-hmm. Yeah, but the increment. What about the increment? Okay. Okay. Okay, but yes, yes. So when does the post increment occur? No, let me ask the question. When does the post increment actually occur? Like when does it occur? What does it do? Hmm. Okay, good. Yeah, that's what I think most of you have said. Yeah. Okay. So here, as the return value of a post increment operation is the original value, not the modified value. And here the original value is 2, and that is what is returned back here, and you have I equal to 2 being saved. And the post increment operation does not at all happen because you are assigning the value to the same variable, and you have I equal to 2 being saved, and you have that being printed. Now what if I had written say int j equal to I plus plus? So what would have happened? And say I'm printing j as well. So what would be the value of j here? Think and answer. No, answer. No. What about this? Answer this part. Like okay, 3 comma 3. Why? So do you mean to say that the assignment operation will happen after the post increment operation? Good. So the answer here will be 3 comma 2. Yes. uh, you are correct. So I plus plus j is equal to I plus plus. So j is equal to I, then I is equal to I plus 1. So j is equal to I means j is equal to 2, and then I is equal to I plus 1, that is I is equal to 3. So you have 3 comma 2. Now let me ask this. This is getting interesting. So let's ask another question. So not int. Let me say I write I is equal to I plus 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 1, and then I print I. What will happen in this case? Can someone answer this one? 3. Okay, okay. I'll hear both of your. Okay, no. Can you repeat that, Manju? Mm-hmm. Yes. Okay. And that is stored in I. Okay, so I becomes 3. So what was okay, fine. So Satyan, what did you want to say? 3? Okay. Yeah, it's 3. S- Correct. So uh okay, let me put a appendix to this. So I will be 3. So this is the case where I will you'll get value of 3, but only after, what am I writing? Only after C17. Okay. So the rules were updated in C17 version of C, and after that, whenever you run this kind of an expression, you will get answer of 3. Before that, you would have got undefined expression. You would have gotten warning that the expression is invalid. You cannot have such an expression. You would have got such a output. But thankfully, the programmers are good enough, like the developers, they have defined a particular case where whenever you write this kind of statements, you can still. So this basically the thing is this entire thing will be evaluated, and then the storing operation, like the assignment operation, will take place, not before that. Okay. So yeah, I hope I hope everyone uh, got the got the essence of what is exactly happening here, why the answer is 2 in the original question. Okay, sorry. Okay, so I'll just move on to the next question. I had a like this is a coding question. Like from week 4, you have to submit some codes, right, in your assignments. So this particular code is regarding. I have already written the answer, so you don't need to figure it out. So basically, you have to write a code to print the Fibonacci sequence up to n terms. Say n is, I'm taking n to be 10 here in this particular code. So the Fibonacci sequence is 0, 1, 1, 2. So it's the addition of subsequent digits. So 0 and 1 starts with 0 and 1. You add both of them. That is your third number. So 1. Then you add 1 and 1, which is 2. Then 1 and 2, which is 3. Then 2 and 3, which is 5. 3 and 5, 8. 5 and 8, 13. So you keep on adding the consecutive digits and you get the next digit. So here we start with 0 and 1, which is x and y. X is 0, y is 1. You have to go till 10 terms, and you already have the first two terms. 0 and 1 are the first two terms. So you need to go till only 8 terms. You need to find out only 8 terms now. Alright, so that is why I have started the counter, the iterator from 3, which is this I. I've started it from 3, and I'll go till 10 because 10, the number of terms I need to print. So I can write this n instead of 10 here. So plus plus I, this is the increment part. Now, what do I do with y? So the first iteration, what happens in the first iteration? So I have y is equal to x plus y, which is 0 plus 1, which gives 1, and x equal to y minus x, which is 1 minus x, x is 0, so this is still 1. So, and I print y. So before that I had already printed x and y, so you had 0 comma 1 already printed. Now I am printing y again, so 1. Okay, now we go to the second iteration. So what happens in the second iteration? Y equal to x plus y again, so 1 plus 1, we print 2, sorry, we have 2. Then x equal to y minus x, which is 2 minus x, x is 1, so we have 1, and I print y, which is 2. Okay, now I go to the third iteration, and what I do is, again, y is equal to x plus y, which is 1 plus 2, we have 3, and x equal to y minus x, so 3 minus 1, which is 2, so I print 3. Okay, the fourth iteration, y is equal to x plus y, so x plus y, 2 plus 3, 5, x equal to 5 minus 2, which is 3, and so on. So this is how it's going to continue. Okay, so I hope you understand the logic. Basically what we needed to do, you can do it in a much easier way if you think. So you can take another temporary variable which you can use and store. So I can do it like this. So I can say tmp is equal to x plus y, and I'll print tmp because that's my next digit, right? So I'll just print tmp. Okay, so the first one, 0 and 1 will be added. I'll have 1 and I'll print that out. Okay, now what I'll say is this will be the new y, and the current y will be the new x. So x is equal to y and y is equal to tmp. I can write it like this as well. So this is a much simpler way to write. You don't need any further. You can use another temporary variable for this, and you can do that. But this is a way without using a temporary variable to do it the way that I have written previously. But yeah, you could do in a easier manner in this way. So here you just, so the order is like this. So your x is 0, y is 1, tmp will be 1, and then your y value will go to x and tmp value will go to y, and again in the next iteration both will be 1 and 1, so tmp value will be 2, and x will still become 1, which is the value of y, and y will become 2. In the next iteration, 1 and 2, you print 3, which will be tmp is 3, and x will be 2, y will become 3, so and it goes on like that. So this is another way to write this code. I hope this is fairly clear to you. Are there any doubts? Okay. All right. All right. Fine. So this is more or less what I had to cover in this particular tutorial class, and yeah, I can discuss if you would like. I can discuss some concept like sequence point. Earlier, I had shown you that logical AND operator behaves like a sequence point. Uh, yeah, I can probably yeah, I can make. What do you want me to? Do you want me to cover that? Because it's not really relevant to this course. But yeah, like it's a bit advanced, but yeah, I can probably cover that. Yeah, I can. Otherwise, I can just start a poll and you can just answer there. Will that help? So you can answer in the polls whether I should be covering sequence points. It's already okay. It's already time, so yeah, we have to take that decision. So last date for exam registration. I'm not sure. You can find it on the course page. Okay. Yes. Did anyone have any questions? Yeah, yeah. Basically, that's what I'm asking. Like, it's not mandatory. Like, it's not relevant to this particular course. But would you like to know about sequence points? It's not. Yeah. Okay. Okay. Good. So this is a link that I provided. Um, so where you'll find the details of sequence points, which has been explained from a C++ perspective, but it more or less kind of holds for C as well. There is not much difference apart from the objects part. There is not much difference for the C. Okay. So before that, earlier I told you that let us consider for simplicity's sake. So whatever I'll be telling from here onwards will be a bit advanced and stuff, like comparatively from the rest of like if you don't, it's not necessary for this course. Okay. So saying that, so every operator has, I would say every operator has a return value and a side effect. Okay. Now. Alright, so earlier I used to say that this is I plus plus, say I is equal to 1 and I plus plus, the return value is 1, right? That's what I said. And I plus I, the return value is 2. Okay, so every operator has a return value. Now there is something called a side effect of every operator, and that happens at the same time. So if I say that, um, okay, all right. So I would say that the side effect is the addition part. Okay, I have written it here. So side effect is the effect of what happens. Like the side effect and the return value are synonymous in that sense that the side effect happens. That is why you get a certain return value. Okay. Now the return value in both the cases the side effect is the addition simply. Okay. But in just having this plus plus I and I plus plus expressions. Okay. But okay. So if you are thinking that the increment in I plus plus, like postfix increment, it occurs after the evaluation, that is not really, it's not very correct in the sense that if I try to pass this value to a function, so say, I'm sure you guys are a bit familiar with functions, so I can probably explain it from this perspective. So if I say that f of I plus plus, if I am writing this, so what value is going in this function call? What value is going to the function f? So definitely the function is taking the value of 1, but when is the increment occurring? Is the increment occurring after the function has been evaluated? No, it's not occurring after the function has been evaluated. It's occurring at the same time that the function call is occurring. The I value is incrementing automatically to 1, sorry, to 2. Both of the operations occur at the same time. So you have, so when you write this post increment operation, you have f of, in this case you have the return value you get as 1, but the original value is returned, but at the same time the I value increases by 1. So both are simultaneous operations that are occurring. Although it increments the value by 1, it will return to you the previous, the original value. Okay, so the I value increment has incremented to 1, from incremented by 1. The I value has become 2, but I plus plus will give you the older value that was there, that is 1. That is what happens. It's not like, it's not that the increment occurs later. No, the increment occurs at the same time, but you don't get that incremented value to, like, it does not return that incremented value to you. It returns you the original value, the old value, but the increment has occurred already. Let that sink. Okay. All right. So sequence points. This was some trivia knowledge. Now, sequence points. Why I said that, this and we wrote an expression of this, j plus j, and this was like this. Let me say we are printing this no matter what we are doing. So I said that this is a sequence point. I said that this is a sequence point, right? So what is exactly a sequence point? So the definition of a sequence point in any, in programming, mostly used in C and C++. So a sequence point is a portion of the program when it is reached, all the side effects of all the evaluations before it is completed before the sequence point progresses. Okay, what does that mean? So here you have a I plus plus operation here, and then you encounter this logical and, which is a sequence point. Okay, now because of the sequence point, what the sequence point says is that I have whenever I'll proceed beyond this logical and only if all the effects and side effects of all the operations that occur before this logical and are completely evaluated. Only then I will proceed to, proceed beyond this, logical and. Is that clear? Like what I'm trying to say? Come again. I couldn't get you. Sorry. Okay. Okay. So sequence point is basically a point or a certain portion of the code, or okay, it's a point in the code where if you want to progress beyond the sequence point, all the operations that occur before the sequence points and their side effects have to be completely evaluated and taken care of. Only then you can proceed beyond the sequence point. So here in this case, the logical and is a sequence point. So this I plus plus and whatever operations were before it have all to be evaluated. Only then the program will proceed beyond this logical and. That is what a sequence point means. So that is the reason why the logical AND does not go and check the second quadrant. Sorry, second expression. It's a sequence point. It evaluates whatever is there in the before the sequence point, and we found out that yes, the expression value is 0. Because of that, we evaluate that, we got expression value is 0. And then and we know that for an AND operator it doesn't make sense if you have one of the expressions as 0. It does not matter, we go and give the value of 0 to that. So that happens because AND is a sequence point, and we evaluate everything that is before I before and that is also because, let me tell you in this manner. Okay, okay. So in this case, I value was 0, j value was 1, right, if I am not wrong. um, okay, so first what happens is it goes and it checks I and, okay, then I plus plus happens. Okay, let me write 0 and, okay, 0 and I plus plus happens, but this happens, this 0 and giving this value of 0, this happens after this operation. It's a bit difficult to explain. So what happens here is, you get, when you write I here, when you write I plus plus here, so the evaluation that happens is with I, right? This happens, okay, but before this evaluation happens and you get a value of 0. Okay, let me write it in this manner. No, this is. Are any of you able to get what I'm trying to say here, or is it difficult? Yes, that is true. That is true. But what I'm trying to say here is that your when you write I plus plus, then you give a logical AND operation. So what happens is, the value that gets returned to this AND operation is 0, right? But the AND operation, it's, yes, yes, but the I value is 1. You get my point. So before the AND operation actually goes ahead and checks that the first expression is false, the I value has incremented to 1. But what we got as a return value from I plus plus was 0. Okay, that's the point I'm trying to make. So by the time this AND operation evaluates and we get the entire thing to be false, i's value has already increased to 1. So I'm talking about the order now. It's earlier we just thought that mm, the entire conditional thing will happen first and then our I will increase. No, it's not like that. So this is how it occurs in the code, actually, in the compiler. Okay, is that clear more or less now? Okay, so that's basically the sequence point, and every semicolon is a sequence point because that is the end of that statement. So whatever pending operations are there before the semicolon, everything happens, and then the semicolon takes you to the next statement. Okay, so semicolon, all semicolons are sequence points. Then there is another sequence point, which is the comma operation, which is also quite interesting, and that is the reason someone among you had asked why, when we write say x equal to 5 comma 6 comma 7 or something of this sort, say in this braces, so why does the x take the value of 7? So this is the reason. Comma actually is a sequence point, so everything that is before the comma will be evaluated before we go to the next one. But in this case, we don't have anywhere to save it. So here you have the value of 5. So this is an expression. This is an expression 1. and this is expression 2, and this is expression 3. So you evaluate expression 1, then and only then you move to expression 2, because you have a comma operator in between, and comma is a sequence point. So you have to finish whatever operations you had, whatever side effects those operations had, everything you have to finish it before you go beyond the comma. Okay, so this expression is completely evaluated and you have the value of 5. Then you go on to the next expression, which is expression 2. So the same thing happens here. So it just goes thereafter, and finally it settles on the last value is 7, and that value is the one that will get stored, because that is the one that is now getting assigned, because this comma operation is over. Now whatever value will come from this final expression will be assigned to x using the assignment operator. Okay, it's it's not that tricky, but the only this part is important to understand how this plus plus the postfix plus occurs. That's all. By the way, in the previous question, if I had, say here I wrote plus plus I plus 1, what do you think the answer should be? I is 2. Okay, the answer should be 3. Why is that? No, this is the pre-increment, the prefix increment. So here the case is completely different. It returns to you the modified value. So yeah, the modif yes, the answer will be 4. Yes, first it increases the value of I by 1. I becomes 3. Then that is what it returns here, and then again you add it with 1. Then I becomes 4, and that is being saved in the assignment operation. So you have answer of 4 here. Okay. Okay, all right. Anyway, so those are like a brief overview of sequence points. I've sent you a link. You can just look into the variety of things that the sequence points can explain. Okay, or rather, you can explain using sequence points and sequencing of operators. And yeah, so that was all for this tutorial session. So thank you for joining. We'll meet again next week, um, Tuesday, 7 to 9.